Every CMMC Level 2 assessment faces a singular point of failure. It happens the moment a DI/BCAC lead sits across from your team, points to a single line in your system security plan, and asks to see the source documentation. Behind that single line is an operational reality defined by evidence sprawl and stale plans of action and milestones. Senior consultants spend the majority of their billable hours manually mapping files and managing version control across disconnected spreadsheets. Traditional compliance tools rely on dashboards that act as passive, lagging indicators of readiness. They visualize the distance to the goal without providing the mechanics to bridge the gap. Athena integrates the entire assessment lifecycle into a single auditable workspace, allowing work to move forward between manual reviewer sessions. This environment collapses scoping, evidence collection, and the generation of machine-readable artifacts into a single unified workflow. Surviving a C3PAO audit requires a shift toward the autonomous synthesis of artifacts, ensuring that every claim in the assessment is backed by verifiable, machine-readable evidence. Reliable AI synthesis is impossible when the system is fed unstructured or unverified data. To produce auditor-grade artifacts, the architecture must first establish a foundation of cryptographic integrity. Raw assessment data enters the evidence vault and converts to normalized data. Each artifact receives a SHA-256 hash, ensuring the system operates only on verified material. Every node then tethers to a canonical NIST control ID, like 3.1.1, creating a rigid structure for subsequent analysis. This mapping creates a shared language used across the policy, evidence, and assessment modules, ensuring the platform remains synchronized. By establishing this normalization layer, the architecture guarantees an unbroken chain of custody. The AI never operates on moving targets or unverified files.
Standard large language models natively hallucinate, which conflicts with the deterministic requirements of federal compliance audits. The extractor model, constrained by an anchor bias guard, generates conservative drafts. These drafts are hidden from the user and intercepted by an independent critic LLM. The critic rejects false positives, and these rejections are injected into the extractor's next prompt, improving logic continuously. This self-critique pass filters out low-confidence drafts at the right time stage, reducing the burden on human assessors. By refusing to rely on a single model, the architecture isolates and removes the unpredictability that typically disqualifies AI tools from federal audits. The extractions that pass the critic move to the user for final review. Here, a senior consultant provides the definitive judgment on the surviving gap candidates. When a reviewer modifies a draft, the system captures a structured data diff. These diffs aggregate into a fine-tuning dataset to learn from expert corrections. Deployment requires a golden corpus evaluation, demanding 3 consecutive successful runs before any new model version promotes to production. This pipeline ensures reviewer corrections result in systematic improvements, guaranteeing that no change to the platform is deployed without passing regression testing. In many assessments, readiness is measured by qualitative feelings or generic scores that fail to predict actual audit outcomes. Athena calculates a canonical defensibility score for every control, weighting closure, sufficiency, evidence freshness, and grounding. These variables continuously recompute using live signals from the evidence vault and reviewer workflow, providing a real-time, quantitative view of your audit readiness. To prevent false confidence, the formula applies a penalty when there are insufficient signals, ensuring that new deployments reflect their true, unverified state. Audit defensibility is transformed from a subjective claim into a continuously snapshotted mathematical value. Between active reviewer sessions, the platform maintains the assessment posture through background automation. Every night, the system executes a sweep to recompute defensibility scores and identify any regressions in the evidence corpus. When evidence ages past its freshness band, the system flags the regression and reopens the relevant plans of action and milestones for remediation. The Wargame Director autonomously selects untested controls and adversary personas based on identified patterns in the assessment data. This triggers a simulation of an assessor versus defender drill against the evidence vault, automatically drafting POA&Ms for any controls that fail the rehearsal. These autonomous loops ensure that compliance is a proactive, continuously maintained state rather than a single point-in-time event. The ultimate goal of the architecture is to produce the machine-readable deliverables required for a successful submission. The platform synthesizes the finalized data into concrete artifacts, including OSCOW-formatted system security plans and EMAS-ready bundles. We return to the moment an auditor points to the documentation and asks for proof. Every artifact includes a provenance trail. Tracing the logic backward reveals the specific model version used, the critic's verdict, and the original SHA 256 source file. The snapshot ID ensures this trail is an immutable record, showing the auditor exactly what the reviewer saw at the moment of approval. For channel partners, automating the mechanical triage and mapping work significantly reduces the cost of delivery. By leveraging a governed AI architecture, senior consultants shift their time away from administrative typing and focus their efforts purely on expert judgment.